And now variation of the stress vector, that is all the forces that acts upon the element of del S are considered to be uniform. That is, in every single direction it is considered as constant, because otherwise there will be some changes and the thing we are talking about might start to, or might try to start to flow. And that is Tn, that is actually a tensor. Probably Kostov sir has told you this. That is del Fs by del S. Because we have three terminologies in a three-dimensional plane where del Xx, del Xy, del Xz, del Yx, del Yy, del Yz, del Zx, del Zy, del Zz. That is the tensor. And if you try to solve it with MATLAB or Python, suppose you want to do this, and then you can do it in terms of by keeping the vector in a plane matrix state by inducing comma, third brace, comma, third brace, or you can also do it in MATLAB where comma, comma and comma, colon, comma, colon, comma, colon. Okay, and you can get an idea that how that looks. And if you try to multiply this by, suppose, a column vector to understand, you can also do that. As the same total, now it is very important that if you try to draw a block, the rectangle, if it's the force, Ni surface force, as the same total force F acts on the vertical and inclined cross section, the stress vector acting on the, that is, if the psi is 30 degree, then keeping this in mind, it will be 30 degree, and Ni into, it will be sine 30, and along this plane it will be Ni into cos 30. So obviously Ni, you know the value, and these are all tensors. Remember this. The horizontal load, if is distributed over the area and contributes to the horizontal force stress F by A. So the orientation of the surface must be given. Obviously, if you want to know, if you don't have the value of IPSA, then you cannot redistribute the amount of stress that will be redistributed within an angle with respect to the surface, and that's why you need to understand this. And whenever you will be understanding this, you will also get some idea regarding if you see someday a microfracture under microscope. Okay, and the microscope, they can be used to analyze these things. Petrographic microscope. If you collect a rock from a shear zone or a rock of gneissic and deformed fabric, and the rock is oriented, and if there is some mineralogical orientation, you might be able to analyze this, how much of force was acting by the time of the tectonic deformation was there, as well as you can also do some CPO, that is crystallographic preferred orientation study, from the other instrumentations that we have in geology, and you can also analyze the orientation of the crystallographic axis of different planes. However, it is not as similar to this. The stress vectors on the horizontal sections are vertical and completely unrelated. In other words, prescribing the stress vector that acts on the point P upon small surfaces of the element given orientation N is not sufficient to define the local state of the stress of the material. Tensor. Now, the numerical representation of a vector always depends on the choice of the frame of the reference. That is, I was trying to tell you that whenever we are trying to have an area, its angle, its orientation, or on which plane we are going to analyze this through, it totally depends upon us. However, nature has its own way to show it, and we have to analyze those in first. Like its geometrical image is an invariant object that is completely independent of any frame of reference. Analyze analogously the quantities, that is sigma, tau, that is del can be reversed as tau, tau xx, tau xy, tau xz, tau yx, tau yy, tau yz, etc., etc. And the changes induced by the change in the reference frame are governed by well-defined transformation rules. And actually these rules, which we have discussed earlier, identify the 9 quantities, that is sigma 1, tau t1, that is sigma 1, that is tau 1, 2, that is tau t1, because these things, when you will be getting more into more depth, you will see that tau, sigma 1, 1, sigma 2, 2, sigma 3, 3 are actually the normal vectors acting on a surface. However, the sigma 1, 1, sigma 1, 2, sigma 1, 3, tau 1, 2, tau 1, 3, and tau 2, 1, these are what? These are surface vectors. Now, whenever we will be seeing under microscope a grain of amphibole or a grain of pyroxene, whenever we will find some amount of fracture or tilting, okay, in some high grade rocks, high grade amphibolite or high grade mafic, then you will see that there will be many planes which are oriented, haphazard, fractured, and somehow they are showing some slip planes like this. Then you will be understanding that how the stress might have acted from this or this. You will get at least an idea. And a tensor is a mathematical quantity that can be used to describe the state of physical property of a material. We represent a tensor by a set of scalar components referred to a particular coordinate system. Okay. And as I have told you, that is there is a state of stress, and in a three-dimensional plane or three-dimensional axis, this is how we can rebuild this. If this axis is T1, T2, T3, in general, the 9 components that I have discussed are required to define the three-dimensional stress at a point. Of these, 6 are independent of, however, because the moments of the forces acting on the cube taken about coordinate axis must sum to 0. That is, sigma xy is equal to minus of sigma yx, sigma xz is equal to minus of sigma zx, and sigma yz is equal to minus of sigma zy. Because otherwise there will be some disbalance in the system and the system might not work and it might break, and that's why to maintain the stability they must be equal, and we need the surface to be mechanical in mechanical equilibrium at a given state. As in the case of the tectonic problems, accelerations may be consumed by negligible. Sigma 1, 1, sigma 2, 2, sigma 3, 3 are representation of the normal vectors that I have told you. And the principal stress components, there is a unique orientation for any point in a body where the tau xx, tau xy, tau yz and tau zx will be equal to 0 at the unique point. That is, the acting shear stresses on a surface will be 0. And for this, the shear stress vector coincide with the limit normal vectors. In case two perpendicular planes of the element now, how to define them or how to create some signs with them?